Viewing a film on celluloid or on video is an audiovisual experience. But we often tend to ignore the contribution of the audio to this experience. We almost take for granted the soundtrack accompanying the visuals and forget that the soundtrack has been designed and constructed as painstakingly as the visuals. In order to do justice to the soundtrack, the students of cinema or videography have to be thoroughly familiar with the nature of sound and its behavior. For some, sound holds the key to the mystery of creation.
The importance of sound has been evident throughout the history of the world. Sound has been an important source of warning signal for the survival of the man and animal. It has been a source of joy, recreation, and its finest form of expression we find in the best form of communication, that is the speech.
This is the basic point of everything in the world, Srishti, Sthiti, Laya. So that Srishti, Sthiti, Laya has been put into one syllable, and if you can properly pronounce it in that way, you'll be revolving like that.
For others, it creates an imaginary world.
When I started working here about 10 years back, we always used to work the night, and I kept hearing these little beautiful bells in the morning, and to me they sounded like there was a Buddhist monastery somewhere around, and there were these wonderful bells that played every morning, and I never found out for many years what it actually was, because it always happened very early in the morning when it was completely dark. And one morning I was very surprised to find that it was actually, after the light came on, I found that it was actually a big herd of goats that they have over there, and all those goats had these lovely bells below their necks. So it's that little game of trying to imagine that there's this lovely monastery. Of course there's no Buddhist monastery here, but then one day you realize that it's something completely different.
And for still others, it is positive energy.
I think that jazz really speaks about the ability of human beings in general, no matter where you come from, to be able to take adversity and translate it into something that's really positive, something that's creative, something that's medicinal, something that's nourishing for yourself and for others. That's what I think jazz is.
But essentially,
sound is a mechanical energy which propagates in the form of waves through a medium.
Sound is created when a vibrating object sends out compressions and rarefactions in air at regular intervals. and when there is an ear to intercept these compressions and rarefactions.
The term sound refers to the sensation that is produced in our ear, and it also refers to the physical cause which stimulates our auditory nerve, producing sensation of hearing. The physical cause which produces sensation of hearing is the objective aspect of sound, and the sensation that is produced in our ear, that is forming the subjective aspect of sound.
So, sound is a wave that requires a medium for its propagation. The particles of the medium get locally disturbed by the vibrating object, and the disturbance is transferred from particle to particle, from layer to layer.
By wave, we mean a disturbance which carries energy from one part of the medium to another part. The definition that I have given is the definition of a mechanical wave, to which sound wave belongs.
A disturbance like this is a transverse wave, because while the individual rods vibrate up and down locally, the wave moves in the forward direction. The disturbance traveling through this slinky is a longitudinal wave, because the local back and forth movement of the coil is along the same line in which the disturbance is moving. Propagation of sound is very similar to this wave of compression passing through this slinky. The particles are set into vibration locally, and they vibrate in the same plane in which the disturbance travels. Anything that vibrates with a frequency greater than 20 cycles per second and less than 20,000 cycles per second can create sound.
When you see some smoke, what is your conclusion? Conclusion is there must be a fire. Similarly, when you hear some sound, if you trace the origin, you will find that there is a vibrating body.
Here, for example, sound is produced by the paper cone brushing against the teeth of the wheel. The finer the teeth, the more frequent are the contacts, and the higher is the pitch of the sound. In this siren, sound is produced by the air blowing through the holes in the wheel. The holes along the circumference of the wheel are more frequent, so the nozzle at the edge of the wheel gives out the shrillest sound. The smallest rod in this xylophone vibrates the fastest, producing the highest pitched note. The thinner strings in the guitar vibrate faster and produce notes of a higher octave. The thicker strings produce baser notes. The frequency of sound waves is measured in cycles per second, or hertz. The frequency of this sound, for example, would be around 100 hertz. The frequency of the sound given out by the thinner string would be in the range 300 to 400 hertz.
down to heaven, so I got to be good, so I can see my baby when I leave this world. We were out on a date in my daddy's car.
The difference between the sound of a male and a female voice is caused by the difference in the tension of the vocal cord. The vocal cord of a woman vibrates faster, giving out compressions in the air at a faster rate.
I'll never forget the sound at night, the screaming tires, the busted glass, the painful screams that I heard last night.
Objects, animate or inanimate, are capable of producing the most unexpected of sounds. Who would have thought that this commonplace corrugated pipe would be capable of producing such a melodious sound? The same pipe, blown in a different way, would produce a completely different sound. A skillful musician can turn the most ordinary of objects into a versatile musical instrument.
Okay, the coil can go like, I just do my...
The beauty of sound is in its abstraction. On hearing the sound, it is sometimes not possible to guess its real source.
The galloping of horses, basically, it's like with your chest, and your hand, you go...
If hands and chest can produce the sound of galloping, rhythmic gulping can produce the sound of heartbeats.
Now that's a heartbeat. You get you open your mouth and close it, you get a different type of goat, right? So you got. So you can have a full herd of goats, man.
Whatever be the source of sound, and whatever the frequency, all sound waves travel through air at the same speed, approximately 340 meters per second. That is, approximately the velocity of sound in air at room temperature. At this speed, the two successive compressions for the higher note are at a distance of 0.67 meters, and the two successive compressions for the baser note are at a distance of 1 meter. For a still low-pitched sound, the compressions are 1.3 meters apart. This is simple arithmetic. Let us presume that this tuning fork is giving out 512 compressions in air in 1 second. This means every 512th of a second, it is giving out a compression. By the time the second compression is given out, the first compression has already traveled 340 by 512 meters in air, 340 meters per second being the speed of the compressions in air. So the distance between the two successive compressions is 340 by 512 meters, or 0.67 meters. By the same logic, when the low-frequency tuning fork gives out the second compression, the first compression has moved ahead by 340 by 256 meters, or 1.3 meters. The distance between two successive compressions is called wavelength. The higher the frequency, the smaller the wavelength. To express this phenomenon mathematically, we may write velocity as the product of frequency and wavelength. Velocity of sound depends on the medium through which it is propagating.
Each and every medium cannot transmit sound wave. The medium must have specific properties. The property number 1 that I mentioned is the continuity of the medium, and the property number 2, that is the elasticity of the medium. And because of this, a heap of sand cannot transmit sound wave, because a sandy stretch is not continuous, it is granular. And clay cannot transmit sound wave because it is inelastic. So these are the basic properties needed for a medium to transmit sound wave, that is continuity and elasticity.
Velocity of sound in air depends on the temperature and density. Sound produced in the warmth of an auditorium travels slightly faster than in the cool, open air. In a warm medium, the molecules are already agitated. So the disturbances created around one layer are passed on fast to the neighboring layers. How does density of the medium affect the speed of sound? If sound were a sprinter breezing through space, it would have speeded up in an empty, sparsely populated place. But it is a disturbance that is passed on from particle to particle. So the more densely the particles are packed, the greater is the ease with which the disturbance is propagated. Thus, sound travels much faster through water than through air. Through a solid medium like glass, it travels 5 times faster than through water.
No woman, no cry.
Sound travels the fastest through steel because of its elastic properties. When the speed of sound increases, the waves get stretched out. The compressions and rarefactions move further apart. However, since the frequency does not change, it continues to sound exactly the same.
To the beat, everybody on the floor, come on, come on! Let's have some noise! DJ Akash right here, courtesy Red FM 93.
Our hearing experience depends on the number of compressions hitting our eardrum in 1 second.
The roller coaster ride, you guys gotta move on, no standing, no standing!
Before we close, a quick recap of all that has been discussed so far. Being invisible, sound is more abstract than the visuals. So, designing a soundtrack with an appropriate application of sound inputs can pose a greater challenge than putting together the visuals. Sound is mechanical energy that travels as longitudinal waves. An object vibrating with a frequency between 20 and 20,000 cycles per second is a source of sound. Frequency of sound waves depends on the frequency of vibrating sources. Sound waves travel as compressions and rarefactions. Distance between two consecutive compressions or rarefactions is called a wavelength. Sound travels through all elastic and continuous media. Sound travels the fastest through solid media and the slowest through air and other gases. The relation between velocity, frequency, and wavelength of sound is given by a simple formula.